This is the first Lisp lab. This network has OSPF already configured. Each router has a loopback advertised. CSR2 will be playing the role of map server and map resolver. Use loopbacks for all configurations and capture traffic before starting. I already have started the traffic captures here, 4 captures. And let's go to action item number 1. We're going to configure CSR1 as an XTR, and we're going to map the EID 172.16.1.0/24 to the correct RLOC. The correct RLOC will be the loopback that belongs to CSR1, which is 10.1.1.1. And let's go. Let's do it. First of all, I'm going to disable some warnings because the Lisp commands that I'm going to enter are considered to be hidden. So you don't want to get those hidden messages. So logging, console, emergencies, and then router Lisp. Then we're going to set up our database mapping for the network 172.16.1.0/24, and we're going to relate it with an IP that belongs to this router. I'm going to use the loopback, and then I'm going to use priority 1 and wait. And this is priority and wait are used when there are several routers that are connected to the same Lisp site, and the site will have several options to enter the Lisp domain. So in this case, this site only has CSR1 as the connection to the Lisp domain, so not really important for the time being. Next, I'm going to enable this router as an ITR. Next, like ETR, and for the ITR, I'm going to set up the map resolver, which will be the loopback that belongs to router 2. And for the ETR, I'm going to set up the map server which will point to router 2, CSR2, with the key site1 key. So that will be all. This is the configuration that make this router an XTR. That means that it will perform the functions of an ITR and an ETR. So that's it. Let's go to action item number 2. Configure CSR3 as a XTR, mapping the network 172.17.1.0/24 and to the correct RLOC. In this case, the RLOC will be the loopback that belongs to CSR3, which is 10.3.3.3. So let's go and enter the same commands here. Logging, console, emergencies. This is just to avoid receiving these messages that Lisp creates. Router Lisp. Then I'm going to set up my database mapping for the network 172.17.1.0/24, and the RLOC will be the loopback that belongs to CSR3. Priority doesn't matter because this is the only router that connects this site. Then IPv4, ITR, IPv4, ETR, and for the ITR, the map resolver for this network will be the loopback that belongs to CSR2, and for the ETR, the map server will be the loopback that belongs to router 2, CSR2, with key. What key should we use? Site2 key. We're going to use site. This is the silicon site2 key, and the configuration is this. This is the configuration for the other XTR. So let's going to configure according to the lab action item number 3. Configure CSR2 as a map server and a map resolver. So let's do that. Let's go to, first of all, we need to create a VRF definition, Lisp, that, oops, no. Lisp that will use only address-familly IPv4 for the time being, and then we're going to create login console emergency because I don't want annoying error messages. Router Lisp, and then I'm going to generate my sites. Site 1 will have an authentication key of site 1 key, site 1 key. Then it will be expecting for someone to register this prefix. And then site 2 will have this key, and it will be expecting someone to register this prefix. And then we're going to enable the VRF Lisp, then IPv4 map server and map resolver. So that's it. That's the whole configuration in order to have a map server and a map resolver. This is it. Now, action item number 4, ping PC2 from PC1. So I'm going to ping this site 2 from the site 1. So let's do that. And let's, I'm going to have to configure this first. And then this one. Okay. Let's see if I can ping my gateway. And let's see if I can ping my gateway here. Not reachable. Probably I have to configure here the bit 1 on IP address. I need to do that, sorry. This site, the1 IP address 255.255.0, not down. Then this should be able to ping the default gateway, and this should be able to ping the default gateway. Okay. This one is okay. Wrong default gateway because the default gateway is this. Okay, whatever. So I'm going to ping the other side. I already did with the mistake I just did. Whatever. Okay, that's it. Let's go into see the tables here. Show IP Lisp map cache. I learned this destination to Lisp. It will remain in this cache for almost 24 hours. It's been known for 30 seconds, and the rlog for this EID is 10.3.3.3.3, which is the CSR3. And notice that this EID is not included in the routing table. Not in table, but the rlog should be included in the routing table. So let's do another ping here, and I'm going to bring up the capture here. This is the actual ping, the echo ping and echo ping request and echo ping reply. And notice that the information that you will see in this column is incorrect. You will have to go and see the actual real data. You can see that this ping is sent from CSR1 because it has the IP address 10.12.12.1, and it is being sent to CSR3, which is the which has the loopback address 10.3.3.3. Notice that this is an encapsulated ping because it has this header that does not belong to the actual PC where we are firing up the ping. It also uses an UDP port 1281, and destination, in this case, destination is 4341. And this is an encapsulated ping. It is not being sent as any normal ping. It is encapsulated by Lisp. This is a normal IP over IP encapsulation. We have here some Lisp field or header that will allow us to use VRFs, and then inside it is the actual ping from the IP address 172.16.1.1 to 172.17.1.1. This is the actual ping, but it is encapsulated within a Lisp tunnel. So let's see how the messages, the Lisp messages went. For instance, let me see if there is something here, words of being seen. Nothing. Let's see the other capture. For instance, this one. This is the connection between CSR1 and CSR2. CSR1, when we started configuring it tried to do a map register with CSR2, unsuccessful. But once we configure CSR2, it should respond with map notify. So CSR1 is trying to do a map register, map register, but okay, here is the map notify. So the map resolver, no, I'm sorry, the map server will set a map notify after it is ready to a map register. So this is the actual interaction. Now, when the ping went on, that I think that started on the other side because I made a little mistake. And for instance, CSR2 to CSR3. Let me see. This is CSR1 to CSR2. Let me see the other capture. CSR1 to CSR2. CSR2 to CSR3. Okay. Now, at this point, when I did a run ping from site 2 to site 1, CSR3 should have sent a map request for the network 172.16.1.0. So that should have happened at some point. I am not seeing it. Okay, here is the request. Here is the request. Map request. Given I pinged site 2 to site 1, here browser CSR3 asked the map resolver a map request message asking for this IP address. But if you notice, the one that is replying is CSR1. So surely after CSR2 received this map request, CSR2 should have forward this request to CSR1, so CSR1 is actually replying to CSR3. So this request should be sent from CSR2 to CSR1 as a forward. Let's see if we can see it. Map notify. Okay, here this should be it. Here CSR2 is forwarding the map request that it received from CSR3, and it is delivering it to CSR1. So in that matter, CSR1 is replying directly to CSR3. Okay. And these are also using encapsulation because it has an external header, an UDP port 4342, the Lisp header, and then the actual message. Which is a map request. So in order to summarize, when the RLOCs will try to register their EIDs with the map server, and they will be sending a map register message. And then the map server will have to reply with a map notify. And when they are actually trying to reach the other side or another site, an ITR will send a map request to the map resolver, and the map resolver will forward this to the adequate RLOC. So this RLOC, which will be an ETR, will answer directly with the map reply to the ITR. So let's finally go and see these tables. I think we already see that CSR1. We already see the cache. In the map resolver, we can see the registered RLOCs. We can, for instance, enter the command show Lisp eid table. There must be another command that is shorter. I don't have it at hand now. For instance, these are the registrations. So this, for instance, the RLOC 10.1.1.1, which is the CSR1, registered the eid-prefix 172.16.1.0, and the other RLOC, which is CSR3, that has the loopback 10.3.3.3, registered the eid-prefix 172.17.1.0. That's it.